The goal of this video is to introduce the morning surge queue analysis tool from the Stanford-MIT Healthy Elections Project. This tool will help model what happens to a polling place that starts the day with a long line. It can also be helpful for an expected buildup at another time during the day, like after work, but we'll focus on a morning example for some simplicity. The tool will help answer how long lines are likely to persist and how long the line may get in the interim. You'll notice many similarities between this tool and the bottleneck tool, as the inputs are largely similar. This tool can also be helpful in identifying the bottleneck of a process, which is helpful in understanding where lines will form. Here, we assume that the line dynamics are completely determined by the bottleneck. On the right side of the page, you'll see a visualization for a generic surge dissipating. On the y-axis, you'll see the line length, and on the x-axis, you'll see time. The line starts with the beginning line length up here, and on average, dissipates throughout the day until it reaches zero at some point during the day. But there are different scenarios where the line may grow and last a long time, or may dissipate quickly. This tool will help you understand what those parameters will look like. Let's scroll down to the tool to see what it looks like. We have inputs on the left and outputs on the right. The first input is the selection of the system setup. By default, it is a three-step process: check-in, voting, and scanning. But if we click on the drop-down, we can have a simpler two-step process or a more complicated four-step process that includes a health check. We'll stick with the three-step process for now. If your process looks slightly different, choose the one with the correct number of steps and just ignore the row labels. The table needs the number of stations and the average processing time for each of the three steps in the process. Let's input that now. Click into the cell and type the number, and you can click out or hit Tab to go to the next cell. Okay, we have our inputs, and for the voter arrival rate, we'll have 40 voters per hour. And for this input, we want to take the average voter arrival rate immediately following when you expect the buildup to be. In this case, the first several hours of the morning. And once we look at the outputs, we can determine exactly what those first several hours look like. And let's assume that there are 30 voters in line to start. Now click Calculate to see the results. There are two things that happened. First, some calculated statistics for each of the inputs appeared on the right side of the input table. That shows the capacity or throughput in voters per hour of each step of the process, with the yellow exclamation point showing where the bottleneck is or which step has the lowest capacity. In this case, it's check-in. You can also see the utilization of what fraction of the capacity is being used on average. And we can see that for all three steps. Over here on the right, we can see the dynamics of the line. First of all, we'll see that the duration of the surge on average is 5.4 hours. That means that, as we saw on the chart up to the top, between the opening of the polling place and on average when the line dissipates down here is 5.4 hours. Next, we have three different measures showing how long we might expect the line to get during that time between when we open and when the line eventually dissipates, which is on average 5.4 hours, but could be longer. This means that there is a 50% chance that the line will not exceed 32 voters. There's a 75% chance that the line will not exceed 38 voters, and there's a 95% chance that the line will not exceed 52 voters. If we want to understand what principally governs how long a line will last or how long it might get in the interim, we'd like to look at the utilization of the bottleneck step. As I mentioned earlier, the bottleneck is the step that does govern how long the line will last and how long it'll take to dissipate. And when the utilization is high, like 90%, the line is more likely to get quite long. If we decrease the voter arrival rate to, say, 20 voters per hour, which the 45 voters per hour capacity of the bottleneck is more than equipped to handle, and click Calculate, you'll see that the duration of the surge is much lower at 1.08 hours, And we see that there's a high likelihood that the line will not get very long. In fact, we see that there's a 95% chance that the line will reach a maximum of 30 or fewer voters. Now, it might be a little bit confusing because the length at the start of the line is 30 voters, but what this model assumes is that once the line is opened, immediately it decreases by the number of stations in the bottleneck, in this case 3. So there are 30 voters in line, the polls open, and the line drops immediately to 27%. Then we look over, 27 people. We look over here and see that there's a 50% chance that the maximum line length is 27 or fewer, meaning that half the time the line will not grow beyond that initial amount. And there's a 95% chance that the line will not grow to more than 30 people. Hope you found this video useful. Thanks very much.